In order to formalize how security policies should be established and implemented, several security models were designed that would allow developers to measure and assess the security of their developed solutions. Conforming with one or more of those security models ensures that the developed system has a certain level of trust. One of the earlier standards that cover the concept of a security foundation is the U.S. Department of Defense standard called the Orange Book. This standard discusses the notion of a trusted computing base, which is the set of hardware, software, and controls that need to exist to ensure the enforcement of a security policy. This trusting base includes all the system components that could be trusted, which are the components that should be evaluated when assessing a system's security. Those components are responsible for controlling the access to all the system resources, and limiting the actions of the other components. The boundary between the TCB components and the other components is called the security perimeter, which dictates that only secure interactions could occur between them, which are called trusted paths. This ensures that only necessary communications are allowed, and protects the users from being compromised. The part of the TCB that controls access to the system resources is called the reference monitor, verifying that a user has enough authority to access a resource. The components that implement the reference monitors is called the security kernel. Another security model is the state machine model, which states that a system is always secure regardless of its state. This model is based on the finite state machine model, which states that an information system will be in a one of limited number of states at any point in time. An information system state is like a snapshot of the system at a certain moment in time, which would transition to another state if the system receives an input or generates an output. This new state that resulted from the transition should be verified if secure or not. If all the possible states have been confirmed to be secure, then the system can be considered to have complied with the secure state machine model. The next security model is the information flow model, which focuses on how the information flows between different security levels. This model addresses the direction of the information flow, and the type of information that is being transferred. The model's main purpose is to prevent unauthorized and insecure flow of information. Another security model is the non-interference model, which is concerned with the effect of the actions performed by users at a higher security level, on the system and on users of lower security levels. The idea is that the actions of a higher security level user should not be noticed by users of lower security levels, and it should not affect them. This is to prevent lower level users from accessing information of a higher security level, and to avoid any system state changes that might put the lower security level users in an unsecure state.